Hello and welcome to the 2024 User Day, and thank you for joining this session on BOSpulse. My name is Mark Groen. I'm lead software engineer at Dynaflow. I would also like to introduce Thijs Krijger, senior engineer at Dynaflow. So this session is about the new version of BOSpulse. It will consist out of 3 parts. First, Thijs will tell you about the new API 6.18 version 6 and how you can use the new version of BOSpulse to assess whether your system complies with this new code. Then I will take over and I will show you a brief overview of all the other new features in BOSpulse. And finally, we'll end with a Q&A session. So if you have any questions at all, also during the presentations, make sure to write them down in the chat area and we'll try to answer all of them. But first, I'll give the word to Thijs for the introduction and about the new API 6.18 version 6.
Thank you, Mark. In May of this year, 2024, the 6th edition of the API 6.18 was released. And our team has been hard at work to incorporate the changes into this new release of BOSpulse version 5.2. In these next slides, I will show some of the changes that have been made to API 6.18 when it comes to pulsation and vibration criteria. We won't have time to cover all the changes, and we encourage everyone doing pulsation studies to read up on the relevant code changes. The first major change in the code is that Design Approach 1 is no longer acceptable in the context of API 6.18, making Design Approach 2 the default, simplest allowable analysis for compressor systems. Even for the low pressure, low power compressor systems, Design Approach 2 is now recommended. Another change is that the pulsation allowable for line-side piping at low pressures has been changed. Depending on the interpretation, the absolute allowable pulsation level was constant for pressures below 3.5 bars of absolute pressure in the 5th edition of the API code. In the 6th edition of the code, the approach is specified in more detail, and the formula is given to correct P1, which is the allowable pulsation level as a percentage of the line pressure. Effectively, this means that the allowable pulsation levels below 3.5 bars are reduced in the new edition of this API 6.18. Another change is the vibration guideline for the piping, albeit they're only changed in a minor way. With the new edition, a little more vibration of the piping is allowed than previously. So let's head in the program and I'll show how these changes are applied. In this version, we are giving the user a lot more flexibility with respect to the allowable limits that they want to use in their analyses. Of course, the new allowables of the 6th edition of API 6.18 are available, as well as the allowables from the previous versions, the 5th edition. However, it's now also possible to define your own limits, and we give the user a lot of flexibility to do so, should they wish to use it. So let's head into the program and I'll show you how these changes are applied. I'll first show you how to choose between the different versions of the API standard, and then I'll quickly show how we can define our own allowable limits. I've already opened a model, and we will go to the Analysis tab, where we've defined one API 6.18 harmonic analysis. In the options, there will be under Allowable Limits a drop-down with some options. There will be the API standard, which uses the latest version of the API code, and the API 6.18 edition 5 and 6, which you can use to select the version of the API 6.18 code that you would like to use. There's also the custom option. If we select this, we can select which checks we want to do according to which standard. And this can be used to do a little bit of a mix and match of the different standards. For example, we do all our checks according to API edition 6, except for the peak pressure, which we'll do according to API edition 5. This, of course, doesn't really make that much sense to do, but we can also define our own allowable limits for all of these checks, which I will show you in a moment how to set up. So we'll go to Tools and then Database, and then we'll have this category of allowable limits. Here you'll see the different allowable limits that have been predefined. So all the checks from API 6.18 edition 5, edition 6 have been predefined. And there's also the checks for the API 6.7.4 analyses. And there's now also the vibration criteria for the VDI 3842, which can be used when you do a structural analysis. I will quickly show how we can define now our own definition, and I'll, as an example, set up a 1% pulsation allowable of the mean line pressure. We'll click this plus to add a new component, and we'll give it a clear name. And we can add it to a group, and we'll make a new group and call it my limits. And then we'll select the type, and we'll, for this example, select the peak-to-peak pressure type. Now we have some options here, and we'll first go to input parameters to define what will be influencing our pulsation limit. And since we want it to be the line pressure, since we want the pulsation limit to be 1% of the line pressure, we'll select the type line pressure here. It'll give this a constant, in this case it's called P, and we'll select the units of this constant. We'll select that it's the bar, the absolute bar pressure, and then press OK. Select the unit of this limit will also be in bars. In this case, it'll apply to the gas phase elements. And then under rule, we'll be able to define our rule. And in this case, it'll be the mean line pressure, P, times 0.01 to have 1% of the line pressure. I'll save it. Now this category, my limits, has been made. You can name this group whatever you want. And in this way, multiple checks can be set up. But for this example, we'll limit ourselves to just the peak-to-peak pulsation. So we now have already defined our API 6.18 harmonic analysis. We'll put that to the 6th edition. We can make a copy of it, which we'll call the 5th edition. In which we set this to edition 5. We can create another copy, which we'll use to do the check according to our own defined pulsation limit. So we'll start with going to setting this to custom, and then for the peak-to-peak pressure for the pipe, we can now select from my limits the peak-to-peak pulsation, and it needs to be 1% of the line pressure. When we want to run this model, we'll select the relevant scenarios and the relevant analyses that we want to run. press the run button, it will take a few seconds to run. And then we can compare the allowable limits that have been defined within this analysis. So there are a few differences between the API 6th edition and the 5th edition. For example, the allowable force for the pulsation dampeners has been changed a little bit. So if we compare by selecting the 6th edition and then control clicking on the 5th edition, we'll be able to see both graphs, and we'll see that there's a little bit of a difference. Then if we also control click on the peak to peak force, we'll see that in this case, for this specific model, both the analysis according to the 5th and the 6th edition for this pulsation dampener are acceptable. In this way we can also select the allowable pulsation, and we'll select that for a line element. And now for the 6th and the 5th edition, both of these lines completely overlap, since in this range that we're working in there's been no change. We can also select our own pulsation limit, which now shows that it's a constant of 1% of the line pressure. And this concludes this section on defining your own allowable limits within BOSpulse 5.2.
Thank you, Thijs, for this presentation. So besides the addition of the new allowable limits and the addition of the support for the new API code, the new version of BOSpulse has many more smaller and larger improvements and additions. Let's take a look at some of the highlights. In the new version of BOSpulse, we improved the performance and accuracy when running a simulation. So running a simulation, you can select multiple processing cores. You could already do that in the previous version, but now we have optimized the way these processor cores are being used, and the different cases are scheduled, so to make most use of all the processing power available. So running these cases, you'll see that they will start simultaneously on multiple processing cores, and each of these cases itself also includes a parameter study, so multiple simulations at the same time. And furthermore, we also improved the way the harmonic solver is used. So for pulsation analysis, you can select your solution method to be the harmonic solver or the transient solver. So the transient flow solver uses the actual time history of the signals, which made it a bit more accurate than the harmonic solver, which only worked in the frequency domain. But for this new version, we included also nonlinear effects in the harmonic flow solver, which made it more accurate, especially for flows that are close to zero, which makes it now the default option in this analysis, since it's much faster than the transient flow solver. For this new version, the BOSpulse database has been extended with new categories. So opening the database through Tools, Database, we'll find these new categories, such as the allowable limits, assemblies, nodes, elements, and pipe schedules. So the nodes and elements allow you to add element or node components to the database. For instance, if you're using a standard compressor or pump, which you will encounter during multiple projects, you can save the definition and its parameters in the database and make use of this component throughout multiple projects. The pipe schedules, so for the NC steel pipe, the nominal pipe sizes, they were already included in BOSpulse in an implicit sense, but now they are also shown over here explicitly with all the size IDs, the true outer diameter and thickness, and these have been extended with also the ISO nominal pipe sizes, so the DN sizes, but also allow you for custom pipe sizes. So for instance, I've added this GRE pipe series where I defined my own pressure class for 16 bars and 12.5 bars. It has a size ID, so the DN 250 millimeters will translate into an actual outer diameter of 256 millimeters with a thickness of 3. Using this in a model, you'll find this additional field pipe schedule, which you can now also change to, for instance, the NC, and let's say it's a 10-inch, and we'll have that translated to the actual outer diameter and thickness for an NC nominal pipe size of 10 with a standard schedule. But for instance, if we have our custom, we can use the same. So this is a DN 250, and it will give you the actual outer diameter and thickness. Of course, also the fields viewer has been extended with these additional fields. So going to the fields viewer, we can use these additional pipe sizes, so the size ID or the pipe schedule, to see what are the pipe schedules and pipe sizes used in a system for a quick visual inspection of all your elements. The 5.2 version of BOSpulse has been extended to also include support for modal acoustic analyses. So opening a model, simple model with just 5 side branches over here. Under analysis, you can now find the additional analysis type acoustic modal. So running such a simulation allows you to quickly identify any modal modes in your system. So this will allow you to quickly see whether there are any possible resonance frequencies which can be excited if you run your pump or a compressor at a certain frequency. So the modal analysis gives you the natural modes in between different range of different limits, and you can visualize using the slider or the play button the nodes and the bellies of the pulsations over here. And scrolling through the different natural modes, you can see if there are any standing waves in your system, which you already know beforehand to make use of, be aware of. So using this, BOSpulse uses the powerful harmonic solver to quickly give you the results for any system. The new version of BOSpulse also supports importing aerial compressor data. So Ariel is a compressor manufacturer that has a program for calculating the performance of their compressors. The data can be exported to data files, and these can now also be imported in BOSpulse. To do so, you go to Tools, Assemblies, and here you find the aerial compressor type. So as you see, this also allows for even future additional types if they come available. So they can be imported from their text files. We give it the name, and as you see, it will import the compressor elements. So the available information has been specified for each of the compressor elements, and the different loading options and configurations have been imported as different scenarios. As you see, the different throws of the compressors are imported. Any of the fields have been already imported. Clicking on Configure Compressor, we can immediately see the PV plots and the flow plots. And this allows you to quickly run a scenario for different kinds of analyses, and it will also allow you to any updates when this compressor has been changed, to edit the selected assembly and inside your completed system update the compressor elements if required. The new version of BOSpulse also has a new scenario manager, and also the way your scenarios tab is shown over here is a bit different. So you can now select multiple scenarios at the same time if you need to change certain fields that needs to be applied to those scenarios. Of course, you can still go to the main model to have any changes that needs to be applied for the complete for all scenarios. But this also allows you to open up a new scenario manager. This scenario manager shows you all the differences between the scenarios and also allows you to edit those values. So for instance, if you click on a certain element over here, you see the viewer will automatically zoom to that, zoom into that specific element, and you can change the settings of that particular field. And for any compound fields, you can use this editor to change those settings if required any additional settings to be set. Of course, you can still select, for instance, two scenarios and use this button to show the differences between those two scenarios in a sense of a report like this. This concludes the overview of the highlights in BOSpulse version 5.2. Of course, there are many other smaller improvements to be found in the program. For now, we'll conclude this presentation and we'll go to the live Q&A session.